specifically talk about glass and processing, and I'll show you lots of examples. And then I will, after the lecture's finished, I'll upload the source code for the examples onto the shared drive as well. And they'll give you a great starting point for some of your building your apps as well. And then about 3 o'clock, from 3 o'clock till about 5, we've got time for more project work. But Caroline is going to come into the, here, and she's an expert at using processing with glass, so she'll be able to answer any of your questions as well. So let me just start out. I can skip that a little bit. So processing is a programming tool that was developed for artists and designers. It came out originally out of the MIT Media Lab, and the basic issue was that a lot of artists were very visual and wanted to be able to build things, but they didn't have a strong background in programming. And so they designed a language that was easy to code. It's open source, it's based on Java, and it also has lots of support for multimedia and graphics and sound and things like that. And so it's a really great tool, even for programming for non-mobile applications. And so a lot of interactive artwork you see, some of it's done inside processing, for example. So when Android came out, then they made a version of processing for Android. And this one generates a APK file that you can then load onto your glass device or your mobile phone and run as well. So in general, hopefully, I'm not quite sure how much Gun has gone through so far, but sometimes you can be very lucky, and almost any application that will, or development environment or programming language that will build an APK file will run on glass. So you can use processing, or there may be other programming languages or other development environments you can use as well. So the motivation for processing is really around building a system that lets you support interaction really quickly. So mouse and keyboard input, input from audio or computer vision or whatever else. Here's the website you go to. Let me just show you that live, a bit more exciting, I guess. And it's a really, really great resource. So just go back here. There we go. Okay. So this is the main site. You can see, you can download it from here. There's lots of examples you can play with, and you can also browse through tutorials as well. And there's resources on here for books and things like that. So it's a really huge community. There's probably a few hundreds of thousands of developers globally using processing or more. And then you can see on the side here some of the projects people have done with processing. So this is a project, for example, that I've seen live. So it's basically an installation, and when you touch, well, let's watch the video and you can see. So it has these kind of mechanical forms, and when you touch them, they react and respond to you. So in this case, the processing is used. So these are all controlled with an Arduino controller board, controlling all of these the servos that pull the wires that make the devices move around, and processing is running on the Arduino board behind all this as well. So a lot of the interactive artworks you may see in museums or other places may be driven by processing or combination processing and Arduino. And you can go through the website and explore this on your own. There's also videos to learn from it and stuff like that. In addition to the processing website, there's other websites as well. So one of the best ones is this one called openprocessing.org. And this is a community website where you can look at other people's projects. So, and there's, and in many cases they put their own, the source code up there as well. So if we go there, then you'll see, here's, so the processing program are called sketches, and here's a bunch of different sketches that people have done. And in some cases, these will run in the web as well. So let's see if we click through here, for example, because they will also export out to JavaScript and they can run them in the browser. But I'm not quite sure if I've got my Yeah, I don't think I have my JavaScript installed. Oh, we'll see what happens. Maybe it's going to work. Oh yeah, so this one is letting me do this kind of visual swooping on the page like that. So you should try and play around with these a little bit and see what really takes your fancy. And then in the open processing site, you can also download the source code for all these as well. So the code's in the background here. And this one now is doing circles, where I'm drawing. Fractal circles. So it's very visually oriented language. So the basics is when you download processing, that actually comes with its own development environment. So this is a little processing development environment. I'll show you it live here. So here's my version here. I guess I should stop this going. So it's super easy. You just write the code in here, which is called the sketch, and then you can save it, export it, open other pieces of code. You can add more tabs here to have different classes of code, and then you can it'll show errors when you start building the code down on the bottom of the box down here. I'll show you that in a bit later as well. So you don't need to have another development environment separate from processing. You can do it all here. But if you're building very complicated programs, then you can also use Eclipse or some other IDE as well. But for what we're going to do, we'll have very simple programs, so you won't need that probably. So here's what it might look like inside the Eclipse development environment. So I'll skip through a few basics, and then I will show you some more complicated demos, and then help you guys get started in terms of getting the environment set up. So with processing, the minimum amount of code you have to have is these two parts here. You have to have a setup function and a draw function, and that's all you have to have. So in this case, I've also defined a variable. So for example, here's a simple drawing example. So there's a setup function, a draw function, and there's another function here called mouse moved. And this one is called every time the mouse is moved. So let me show you that running, and you see how the IDE works. Okay, so let's just copy these, and I can go back to the IDE. Actually, I need to change one thing here. Okay, so now I can paste this here. So you can see there's all the code there. And now to run it, I just have to hit the run button here. And what it'll do is it will, in this case, it draws a window. And as I move my mouse around, it draws a circle that changes radius depending upon the mouse position. So you can see how that worked in that you had the setup function. The setup function created a window here of 512 by 512. The background color, set it to, that's a little bit dark, isn't it? So if I do, okay. So the background was set to white, and then there's a draw function. The draw function is where all the interaction happens. So basically the program tries to run this function as fast as it can. In this case, it's setting a fill color, which is now red. These are RGBs, and it draws an ellipse. And the ellipse is drawn at the mouse X and mouse Y, so just the mouse position. And then every time the mouse is moved, then it increments this little counter, and it takes a sign of that value and sets that to be the radius of the ellipse. So as I move over here, then you can see it's drawing away quite happily. So even with just a few lines of code, you've got a little kind of pleasing little graph there. And you can see how easy that was to build in the IDE as well. So it's running right now. I can hit the stop button, and it stops the program. I could make some change. So for example, if I wanted to make the background to be black, so change it to 0, and then you run it again. Now it'll draw a black square, and you can draw the same thing happening on the black square. So super easy. So I'll go through a little bit of these things, and then we'll try it with glass. Okay, so that's that. A couple of things. So that's just the drawing is trying to get set as fast as possible. The stroke and fill function set the colours you're drawing, and then the mouse is in position, and then there's also a mouse pressed function you can add as well. Now, of course, with glass, you don't have a mouse, so you don't get the mouse X or mouse pressed functions at all. Some other basic drawing commands. You can use a rectangle command to draw rectangles of a certain size, an ellipse command, a line command to draw between two locations. You can fill objects of colours. You can use a variety of curves and vertices commands as well. If you go to the processing website, then you can look at the reference section, and there's a list here of all of the commands here. So, if I want to look at 2D drawing commands, they're all listed down here. And if you click through any of these, like the quad command maybe, then it gives you an example of how it's used, a description, and what the parameters are as well, and the output too. So websites really helpful. And here's all the language commands based upon function. Okay. So the other thing you can do with processing is you can import other libraries as well. And so because processing is written in Java, it means you can directly import .jar files. And to do that, you just have to just type import in the name of the library, and then and that adds you a lot of different functionality. So here's a number of popular libraries that are being used. So the minimum library, for example, lets you play sounds. There's an OCD library that provides 3D camera views, a physics engine, Bluetooth, and networking, and so forth. And you can find a lot of libraries at this website here called Toxic Libs. So we'll go there and have a look. Not all of these libraries will run on Android, but many of them do. And so, and they all run on the desktop version of processing. So let's go and have a look at this one here. Toxiclibs.org. And so here's a lot of different libraries and categories of libraries here as well. Oh, it looks like they changed their site. Oh, okay, so I guess what it's saying is you have to go to this downloads directory here to find the libraries as well. So if we go here, then there's a bunch of libraries that are available there as well. There are other libraries too, and we'll talk about the Ketai library in particular in a minute. Now, most of you have you've all got some programming background, so I guess are you all familiar with class-based programming? Okay, so I can skip through the next part here. So basically processing allows you to build object-based classes as well. So if you've all done that, it's pretty easy. In this case, it's just the same as what you did in Java or something like this. You declare a class constructor, and then you have the data and the methods, functions, and the classes as well. So here's a class usage here. You're declaring a class, and then the setup function, you create an object, and then you can call the methods in the draw function as you need. So just a little bit on graphics. So processing supports both 2D and 3D graphics, and so it lets you do kind of OpenGL-based graphics. So you basically have things like translate, scale, and rotate commands. You can push and pop matrices to store transformations as well. And doing 3D graphics is two options. You've got this P3D library, which is a very simple, lightweight 3D library. And then if you want to, you can actually install the OpenGL library and have full graphics support, or OpenGL is a lot more complicated as well. So for example, here's a very simple P3D scene. So in this case, they're creating a window that's 640 by 360, so actually the same resolution as glass. But instead of having two options for the window, they add a third option, which is the P3D command, which shows the window supposed to be used for 3D graphics. Then you set some lights here, and what they're doing is they're pushing a matrix and translating the camera by 130 at half the height of the window, rotating a little bit, and then they draw a box. So box to primitive. So this white box here as a result of that. And then do the same thing, translate again, and then draw a sphere. So the sphere over here is the result of that. So using P3D, you can do things like defining shapes and quads and draw vertices with those. So yeah. You can also have transformations as well, so rotation, translation, scale, transformations. It's important to remember, haven't most of you done 3D graphics before? Some of you? All of you? Yep, so you have to remember to push and pop functions to store and save the transformation functions as well. So that's a kind of very basic introduction to processing. As I said, I've given you the books there, so if you want to know more, you can read through the books or you can go online. But I want to talk a bit more about glass because it turns out processing is a really great tool for rapid prototyping for glass. So, oops, I forgot to type here. So, but basically, in order to have this work, you have to have the Android SDK installed, and you have to install the Android mode on processing. So let me show you how to do that. So, in your processing window, you'll see on the left here, there's this button currently set to Java. If you click on it, and if you haven't installed Android mode, this won't appear, but there'll be a button that says Add Mode, and you can click on this, and then that lets you add different modes here. So in this case, you click this, and then you click on Android mode, and it would automatically install the Android mode. And when you've done that, okay, I have to quit the sketch here. Oops. Okay, when you've done that, then you should be able to select the Android button as well. So, having done that, let me show you a couple of examples, and then you can try it for yourself. So, first of all, one of the most basic examples is the Hello World example. So in this case, all I'm going to do is just set up the window, set the background to be black, and then create a white foreground text string, and then draw a text string on the screen. So here's the code for doing that. Let me just zoom in a little bit so you can see. Okay. So you can see the code here. So again, it's just got that setup function, a size that creates the window, background, a drawer, and everything like this. Now, if I zoom out again, now I've got my glass installed or plugged in. So I'm going to run this, and because it will detect that I've got an Android device plugged into the... oh, before you do that, did Gunn talk to you about the ADB function? Yeah. I did? Okay, so it's always helpful. Processing is flaky a little bit, so it's always helpful to make sure you've got an Android device actually connected to your, or recognized as being connected to your machine. So I'm just going to run the ADB right now, and hopefully will detect my glass display, and then so there it goes. It detects the device, and it's got the serial code there as well. The good thing about this too is it runs with most Android devices. So, at your home or when you leave the class, you probably won't have access to a glass device for a while, but you can still test this and try it out using your own Android phones and the like as well. So, so it's found there's a device installed. So if I put my pair of glasses on here, then I just hit the run button here, and what it'll do is it'll compile this. It'll generate the ADB file, and then it'll push the file over to the Google Glass display. Now, if you don't have an Android phone or a Glass display installed, in the Android, there we go, in the sketch menu, there's a run an emulator. So if you run this one, it'll actually create a desktop emulator of an Android phone on your computer. It won't emulate Google Glass, but it'll emulate the phone, yeah. So even if you don't have a phone available, you can still play around with stuff. So let me run this, and then while it's running, if you look at the bottom part of the window here, this is the debug window, and you'll see it'll start putting up lots of messages here about where it is in the process, in the compiling process. And so hit that. So here come all the messages. Now, one thing that's important to do is to make sure that when it tries to start installing, you see it says building right now. When it goes to sketch complete and copying, your glass device has to be on. Because if it tries to push the APK file on and it's asleep, then you won't be able to run the file. So it's still building. It takes a while sometimes. And it's almost done. Now it says installing Sketch on my device. The serial code is the same as the serial code here. And it's just starting up. And actually, where is my... So you see here, this is the output on glass. If you've got very good eyes, you'll see there's the hello world appearing right there. So, you know, I could stop that and write something else. Say, hello world, programming glass is so much fun. Okay, great. So now if I run it again, then it'll build it and it'll appear on the display. Okay. So if you set it onto the Bluetooth setting in your device, that keeps the display alive, so you don't have to worry about it going to sleep. And it's so now it's installing it, and still installing, and there it is. Again, I can't read that, but hello, programming glass is so much fun. So that's very easy. So that's pretty straightforward, but also not very interesting. So let's see if we can do some more interesting things as well. So one of the easiest things you can do is you can create a, just like we did 2 days ago when I showed you with App Inventor, you can use processing to load images, and then you can create your own fake glass timeline or fake glass app. So in this case, what we're going to do is we're going to create an image variable. So processing comes with a p-image type of variable, and then we'll create the window again, and this time we'll load an okglass.jpg file, and the okglass JPEG file is just looks like the default one here. So here's the file here, and there it is. So it's just okglass. I made sure that this is 640 by 480, so when it loads up, it fills the whole frame. That, and then once that's loaded, then it's just going to display the image. And this time we use this image function. All the image function does is it loads a picture on the screen, and then the 0, 0, this is the x and y coordinates the picture's being loaded at. So you can see with a very small amount of code, I can throw an image up on my glass display. So let's run that and see how it goes. So first of all, I've got to open the where's the my Mac's having some troubles. If I go to the, let's see, sketchbook, and here's the file here. So it's hello world image, and now you see there's the few lines of code here, and if I run that, then all that's going to happen is it's just going to throw up the hello or okglass image on the screen here. And it takes a while. Okay, here we go. And there we go. So it looks like exactly like what you'd get from running the native Android app. But it doesn't do anything, of course, just puts a picture there. So that's not too interesting, but it's getting a bit more interesting than just having text anyway. Let's go away from that, and we'll try something more complicated. So what you want to be able to do is use a touch input. There's two ways to do this. So I guess Gunn was talking before about how different events on glass maps to different key events. And so if you want to do something very quick and dirty, then a tap on glass maps to a D-pad input on the in processing. And so all you need to do is you need to import the Java class to capture motion events, which are input events, and then see if any of those input events are decode or keycode D-pad events. So normally with motion events, if I'm running on a device with a keyboard, like my laptop, whenever I type on the keyboard, it'll capture those key events and tell me what a character was that I input. Of course, with glass you can't do that because you don't have a keyboard, but it does recognize taps as a D-pad input. So I'll show you the some code for that, and then we'll run that as well. So I go back to glass here and import, file. Oh yeah. Oh, I'll help you in a minute and get it set up, so it'll be okay. We'll go around. Yeah, you have to have API level 10 installed. Yeah. So here's a bit more complicated example. So in this case, I'll go through it really slowly, and you can see. And then once I've done with the, there's only a few more slides to go, then I'll go around and make sure we've all got it working, and we'll get some demos set up. So in this case, you'll see that I'm setting up a bunch of different variables. So here's the, you want to be able to map mouse events or touch events on the touchpad to 640 by 480 screen resolutions. So the touchpad is 1366 by 187 size in pixels. Of course, your screen is 640 by 360. So then I want to take where I'm touching on the touchpad and map that to 360 by 640. So that's why I have these variables here storing the dimensions of the screen and the touchpad. Then you have to create a string event which captures all your touch events. Then I'm going to develop a scale factor that will scale here. So again, I open up a window. I want a black background, and then I'm going to draw an ellipse here. And then I've got this D-pad input here. So this void key pressed is one of the processing functions that automatically capture key input. And so most of these inputs I can't input from glass because it doesn't have D-pad or anything. But if I tap, then it will provide this input here, captured input there. So if we run this, then we'll see it works. So it's just going to draw a black screen with a red circle in it, and then if I tap on the side of the display, then it should print output. But the output gets printed out in the console window here, not on the screen itself. So we have to wait for it to finish its building. And then the next example I'll show you a bit more complicated, and showing how you actually use that output. So right now I can see on my display the red dot, and then on this display here, if I tap, you'll start seeing that it's showing key press and center. So whenever I tap, it's printing that there. So if you want to capture quick and dirty input on touchpad, then all you need to do is add the code for capturing the D-pad input, and then have some function or something happening here in response to that. So you could very easily use this to show a image on glass, and then when I tap, it'll change to another image, for example. So that's again a little bit boring. So let's see if I can do something a bit more interesting. So in this case, what I want to do now is actually track my fingers. And it turns out if you include that Android library, the motion event library, then it'll give you the XY location of touching on the touchpad. And then once I know that, I can then draw on the touchpad and draw the output onto the glass screen as well. So I'll run the demo, then I'll go back and I'll step through the code so you understand it in a bit more detail. So stop things here. And let's see if I go back to... Boy, my Mac is really slow today. So let's see, touchpad test, okay. So this is largely the same as what I just showed you, except there's a couple of small changes, and I'll go through them as well. Okay, so the first change is that, let's go over here a bit. We included this Android motion event library here. So now this, as I said before, it's... did Gunn talk to you about the motion event library at all? Maybe he'll talk to you about it tomorrow. So it's normally with an Android phone, you can capture touch events, and you can use the location of the touch event to cause actions to happen. But with Glass, you're not actually touching the screen, so the touch events don't make any sense anymore because you can't touch in here, of course. So there's one class above touch events, which is a motion event. So every input in an Android phone will normally be captured as a motion event and then translated down to touch event or other types of events. So in this case, we capture the motion events. Again, we've got these variables for the screen here. Now we're defining the touch X position, Y position of touch events. So when we start up, we first of all have to figure out a scale factor. So we want to map the the whole pad width to 640 and the whole pad height to 360. So that's what this factor here does. Then again, we're drawing the black background. We've got this little flag here. So if my finger's touching, then it's going to draw an ellipse. And then this is where the main action happens right here. So now we have to write our own dispatch generic motion event method, or function I should say. So when you use the Android motion event class, it's going to capture the events, and then it expects you to write a function like this to deal with the events. So in this case, here's the events captured. The X and Y, if you get X and get Y, this gives you the X and Y location the event happened at, and then they also classify events depending on different actions. So you can have action down event, which means you're touching down, action up, so when your finger leaves the touchpad, it generates an action up event, an action move event, so when your finger's moving on the touchpad, and so forth. So what I've done in this case is that when action down event is issued, then you set the finger touch to be 1, so now the finger touch is on, and now when the next time around the draw function, it'll start drawing your ellipse. And then when you lift your finger up, of course, it turns off. And if you move the finger, it keeps it on as well. And while you're moving the finger, it finds out the X and Y position using the scale factor before, and then it uses the X and Y position to draw a dot on the screen. So let's see that working. So just go back to the, yeah. If I run my thing here, it just takes, it was a bit slow getting going, but yeah. Okay, now it's installing the sketch. It's about to run it. And so now you see there's a black screen, and when I touch, it puts a, oh, it's really hard to tell, but you can see there's a faint red dot there, but in my display here, it's quite bright. Can you all see that dot going around? So as I move my finger, and actually it's much faster in here than on there as well. But, so that's showing you how you could now map touch events to things happening on processing and on the glass. Now, of course, what you want to be able to do is, if you want to, for example, duplicate the glass UI timeline, you'd then have to write your own code for recognizing swipe events or swipe down events or tap events, and then have something issuing in response to that. So does anybody have any questions yet? Is that all pretty straightforward? And what I'll do is, I said, when I've finished talking, I'll take all of the code here, upload to the shared drive, and also start going around with you guys individually to see if I can get you all working on your own individual machines. So just a couple more things I want to show you. One was sensors. So obviously glass, as you know, has a set of sensors on it, and what we use for capturing sensor input is the Ketai library. So Ketai is the Japanese word for cell phone, and it's an Android library that was developed for developers to easily capture all of the sensor input from your cell phone. So let me take you there and show you website. Okay, so here's the Ketai library here. So here's the types of things that will capture. So it captures gesture input, it captures a location input from GPS, it captures the camera. The Ketai Simple Face, I think, is a simple face recognition software. Bluetooth, Wi-Fi, NFC, keyboard input. And there's a book that describes it very well, and the book is right there, and here's the book here. And if you go online and download, you can download the library from the book, and this has a wide variety of examples in it. So I guess you've got one running on your phone already, is that right?
This isn't Ketai, it's just an telephone.
Oh, okay. Well, that's fine too. Yeah, so Ketai has examples for how you could, for example, take a photograph and then use use networking to let somebody on their Mac or PC draw on an image that was being captured on your cell phone, for example. Or use the GPS to, you have to know where you are, or shake the phone and use the acceleration of the phone to cause something to happen. So there's a variety of different uses for it, and so it's a really great library to have. So let me show you this little video here, and you'll get an appreciation for how it works.
How does a 2-minute Android application look like? First, we download the Android SDK from the website, and also processing for Android, which is free and open source. You can work with all the sensors on the device now: location, cameras, connection built on the cameras, Wi-Fi networking, Wi-Fi direct networking, Bluetooth networking, read and write NFC tags, data, specified databases, and also multiplication. This is what we're going to build now. First, we're going to start with the typical processing sketch, which uses void setup to initialize the sketch and void draw the screen 60 times a second. Then we center the rectangle by translating to half the width and half the height. And draw a rectangle at 0, 0 with a rect size, width and height. We'll set the width and height to 100 pixels and also make the rect node go centered, so this is how it's going to look like. Now, next we're going to get the Ketai library, which is responsible for the actual gestures, and we'll with the UI package, create a Ketai gesture class variable called gesture, and then we can work with pinch multi-touch gestures. It has a XY position and a distance D, and if we take our rectangle size and then increase it by D, we can scale the rectangle like we see it here.
So pinch is an inbuilt function they get with the gesture library.
Also rotate, using also two-finger multi-touch gesture. Also the rotation has a position XY and an angle of power rotation. We'll introduce a new variable called rectangle. We can actually work with it to rotate our scene here. And we'll use the rotate method, and the rectangle to do just that. Now we can scale and rotate. So we don't erase the background, we have also these trails. Next, we introduce color. So if we use a rect color and a fill color without a set rect color, we can actually draw the rectangles with no color. We'll change the color on flick, which is another short gesture to change the color color randomly, so we use the random method to change the color for red, green, and blue. So start with that. We have the final sketch. Besides multi-touch, that helps us looking with sensors, geolocation, with cameras, Bluetooth, Wi-Fi Direct, NFC, data, SQLite databases. So the chapters in this book all individually talk about each one of those classes.
Okay, so you can see how easy it was in just a few lines of code to build a little application that lets you have gesture input as well. So I'll show you a sensor input using Ketai. So in this case, it supports all the phone sensors. You just have to include the Ketai library in your processing sketch, and then define a sensor variable, and then you're good to go. So say we're going to read the accelerometer, for example. We create a new sensor. We start the sensor, list the readings from it, and then by writing the onAccelerometer event, it means that every time the accelerometer changes value, it will set the new values to X, Y, and Z, and you can use those values in your program. So it's a little bit like, well, on Monday when I showed you App Inventor, and they had an accelerometer class there, or accelerometer widget there, and you could grab out the roll pitch in your, actually it was an orientation sensor, wasn't it? So it's a similar approach. So I'll show you the default demo that comes with Ketai library. If I go back to the processing part here, and now if we open up the sensor test, here we go. Sounds urgent, you better take it. It's quite a ringtone. So in this case, oh, it's too big, but anyway, you'll see, so I just import the library. I say what I want to use, so I want to use a sensor class, and then I'm going to create two vectors, an accelerometer vector, a magnetic field vector, and a light. So there's also a light sensor one as well, so create the new Ketai sensor, create new vectors for the accelerometer magnetic field, fix the orientation of the image on landscape, then start drawing some text. So now I'm going to align the text in the middle of the screen, change the size. So when I did the Hello World one, it was very small text, but now it'll be bigger. And then in the drawer function, all I do is print on the screen all the values that I'm getting from the sensors, so the accelerometer, magnetic field, and the light sensor. And then for each of those sensors, it looks, I can just create an event listener. So you listen for the events that come around, and then you can set the variables to the values you're getting from the sensor. So all this little piece of code is going to do is going to continually read the sensor data, and when the data changes, it'll change the values, and it'll then on the screen draw the sensor values on the screen. So let's run that, and we'll see what happens. And if I go to here, turn my Bluetooth on. It's installing, and almost ready. Okay, so now here's all the values. If I turn my head around, you'll see, that the values are changing. And there's a light sensor there. So if I cover my fingers over the display, you see the light sensor goes down. If I take my fingers off the display, then it starts going up again. So you could easily imagine how you could use this for some sort of game where you tilt your head around and a ball bounces around the screen or something based on the sensor input. And you can also get GPS in the same way, and other sensors as well. The last example, actually two more examples I want to show you, is one is the camera input. I don't have a slide for it, but I'll just show you the example anyway. So Ketai library makes it very, very easy to get access to the camera in the glass, just with a few lines of code. So one of the disadvantages you may have noticed with the glass is it doesn't have a viewfinder on it. So if you're going to take pictures, then you kind of guesstimate where the camera is pointing, and you say, okay, glass, take a picture, or push the button or whatever, and you hope that it's taking a picture of what you're pointing at, looking at. So we can use processing to make a very simple viewfinder that we could use. So if it wakes up, okay, and let's see here. So I've got a camera test app, and in this case, it's pretty much the same as what I showed you before. If I just we don't have to we just have to include the Ketai camera class right now, and then we define a camera variable, and then in the setup function we specify a new camera, and the camera is specified as, in this case, the camera is going to take images that are 640 by 480, running at 15 frames a second. So it can record video as well, but and then we have this. We create the 640 by 360 window again, and then in the draw function, all that's happening is that it's taking the image from the camera and drawing it on the screen. We have to move it over a little bit so it fills the whole screen. And then the camera, like other sensors, has its own event, and so this is going to be continually reading from the camera, and every time the camera is completed reading a whole frame of video or a whole image frame, then it fires off this event and puts that image into the cam variable. So just and then the last part is the key press. Now, as I was lazy, I just told you before how you could use a tap to generate a D-pad key code. So I didn't want to write a whole lot of code for tracking my fingers and making a button on the screen that hit to turn the camera on and off. So all I do is that when I tap on the touchpad, it toggles between starting and stopping the camera. So what the final effect will be, if I tap it, it'll start running the camera and you'll see the live video going on. When I tap it again, it'll stop the camera and it'll be frozen. So if I wanted to, I could add more code here that when I stop the camera, it would save the image somewhere, and then I'd have a little photo capturing application. So that's that. So let's see that running. Okay. So now I go back to my Bluetooth screen. Takes a long time. Okay, so now it's installing, and it'll start up and it'll display, I believe, a white image right now. Yep, there's a grey image. So that's not very interesting, but if I tap on the side here, then it will fire up the camera, and now I can see live video on my glass display. Now, the Ketai library and processing is actually, it's on top of Java, so the camera actually runs quite slow in the display here. It's running about 8 or 9 frames a second. If you wrote this in native Java code, like what Gunnar was talking about this morning, then it'll run much faster. So if I'm looking around, it's got the camera running. I can look at Neville here, for example, and I can tap, and it will stop running. And now the picture's frozen, then I can tap again, and it'll start running again as well. So you can see with just, I don't know, a dozen lines of code or so, you've written yourself a simple viewfinder viewer. Okay, great. And the last thing I want to show you is a much more complicated processing app, and I've got several versions, so I'm not quite sure which one's going to work. But one of my students actually wrote a simple copy of the timeline on glass, And so if I run that, that'll show you how you can implement different gesture commands, and it also shows very nice transitions between the cards. And it gives you an example of how you can build a class or an object-based application. Because in this case, each of the cards, here's a card class that tells you, what's on the cards. Okay, so if I go to the sketchbook, Timo, and I think it's this one, although I'm not sure. We'll give it a try. So this is a little more complicated. So I'll skip through the code really quickly and get the idea for it. In this case, you'll notice that when you swap cards on glass, you hear a very small sound, a clicking sound. And so in order to do that, we had to play sounds. So we had to import this app widgets library, which is a very easy way of processing to play sounds. Then we've got the motion event here. Then he's defined a card class. So the card class here gives you the X and Y location of the card, the width and height of it, the various images he's showing on the card. So if you want to build a fake timeline, you want to have 10 or 20 images that can go along there. And then it tells you if the card has any children. So sometimes in a glass app, you'll notice that some of the cards have dog ears on the corner. When you tap them, it'll go down, and there'll be a second array of cards. So these are the children here. And then here's a couple of simple functions about setting the location, drawing an image on the card, or getting the size of the card. So that's the card class. And then I'll skip to the main thing here. There's the setup. So again, you've got to scale your touch events. You have to load up all the images. So in this case, we had a whole bunch of images called 1 to or 0 to 20 or whatever. So we load up the images, and I'll show those in a minute. And then you had to set the start card and draw the card's initial positions. And these functions here, this is for playing the sound. So the AP widgets is a very easy multimedia library, and you just have to create a little player, and then you set the volume, play the sound. So in the draw function here, draws a black background again, and then it looks for different types of touch events. And so if you slide cards along, you notice on glass when you slide the card, if you stop between two cards and lift your finger off, then it snaps the card to fill the screen. So this little event here, this is the snapping function. So it looks for a touch event up. So when your finger leaves the touchpad, then it will see if the cards are between locations, and if not, it will snap them. Or if it is, it'll snap them. And if there's no up event, then it just uses the position of your finger to translate the cards along here. And then if the card is changed, you have to play the little beep sound. So there's a little code that changes the card here. And then here's the different touch events here. So we look when you touch down, and it sees if the card in view, which card is in view, and makes that's the current card. If you have a move event, it looks at the delta X that you've moved in the X translation. If it's moved a certain amount, then it'll translate the cards along. And if there's an up event, it checks to see whether you swipe forward or backwards, and it snaps the card as well. So it's not a lot of code, but it's a bit more complicated than what I've shown you so far. So let's see if that runs. Oh, before I run that, I'll show you also the cards. So if I go here, and it's here, I think. In the data directory, you'll see here. Oops, do that. A whole bunch of cards. So we just went in and grabbed some screen grabs of various glass cards, and here they all are. So just all these cards here. And based on what I've shown you already, you can generate your own fake cards now using the proto.io or some other rapid prototyping tool. So here's all our cards. So let's run that, and we'll see what happens. Hopefully it doesn't crash. It's been a long time since I've ran this code, so not quite sure. Oh, that's okay. So it crashed, and the reason why it crashed is because I haven't installed this package on in this version of processing. It was on developed on a different machine. So this might be a good opportunity for me to import a library. So let me see here. The library's not on the list. So if you some of the common libraries on the list here. So the Ketai library, for example, is on the list already. So in this case, I need to go and install that. So let me just do that. Embarrassing. So if I type in processing and AP widgets, here it is.
Can you use native cards processing? Oh, we can learn that later.
No, so it's well. Sorry, these are all native cards because they're all running on they're all running off the APK on the device itself. So you can basically so they are equivalent of native cards. Yeah. So it's a very different from what the Mirror API that we were saying before. So let's grab one of these. I guess this looks as good as any. And we'll just download that. And this gives me a good opportunity to show you how to install the libraries as well. So now I've downloaded it. I can go to the Finder, find the library, and then processing, at least on the Mac, I'm not quite sure on the Windows, but I suspect it's similar. In the document folder, they create a processing directory. And when you go into this directory, there's a libraries directory here. And this is where you put all your libraries. So if I go into here, and I can paste the library and then unzip it. So you see, for example, there's a Ketai library already, so I just unzip it here. And that's it. And now here's all the library for that. So now if I go back to processing, I should be fine, hopefully. So let's... we'll find out. I can't remember. Maybe, yes, you have to restart, you're right. Okay. Yeah, I was trying to be too smart. Okay. So now we'll restart processing again. And there we go. Make sure I got the right version. And I've got to go back and load up that application again. But it's really that easy to load a library. Just go find the library on the web, download it, make sure it goes into the libraries directory and processing, and you're all good to go. Hopefully, we'll see if it works. So now we go to Timo's one again in the glass. I think it was this one here, wasn't it? Open up that. And fingers crossed. So so every time you, that was a good point, David, every time you have a new library put into the folder, you have to restart processing so it can know it's got those libraries there. It takes a while, but and after this, there's just one more thing I wanted to show you, and then Carolyn will come in and you can have a bit of a play yourself. So now it's installing the sketch on here, and it's going to start it up. And voila, there we go. So now I can slide the cut timeline like you would expect and you can't hear it, of course, but I can hear the clicking in my ear as you start going along. So it's a very easy way to, fake some sort of app running as well. So I'll share this code with you as well. In order to use it, you'll have to install the app widgets library, but that's very easy, like I just showed you. And yeah. So the last thing I want to show you is a bit more complicated application that we've used developing, and it shows you how you can use this for kind of prototyping new ideas with glass. And so let me just get that started. And in this case, it's we're doing some work here in the lab on. Let's see, is it in here? Oh, it's recent, I think. Here we go. So we're trying to do some work at what happens when you see a panorama image using glass. So you can easily load a panorama on the display, and then what you could do is use your head orientation to look around a panorama. So that's what I'm going to show you now is how you can do that. So it's a more complicated because we have we use the sensors, we use other motion events and things like that, and we've got a number of different elements that you'll see as well. So there's quite a few classes and other things here as well. But I'll show you the demo first, and I can skip through a little bit of this as well. And actually, I think Tracy, the student who's working on this, might want to talk to you. She's trying to find a woman to help her with her experiment. She's conducting user studies right now, and she has to have pairs of same-sex people. And she's short, a woman, so she might come and grab you, and then you get a chance to play with yourself. But she'll show this as well. So let's run this on the device, and I can show it here. Oops, I don't want to do that. I wanted to do this one here. Okay, so it's just starting up. This is a lot more code, but the guy who wrote this is actually an Android Java developer, but he felt it was much faster to code up in processing and get something working than it would be to write the equivalent thing in native Android. Okay, it's almost done. Okay, so now it's installing the sketch. So what it's going to show you, it's going to show you an immersive panorama. And as I look around, as I turn my head around, you'll see the okay, I've got it here. So here's the panorama image, and I can turn around, and my head, the image rotates as my head position. It's slow on there, but it's faster on here. You'll also see there's a little circle in the middle. This is, those of you who play games, you'll often have a radar display that shows where other people are in the environment. This is our version of that. And this app is supposed to be a networked app, so it's supposed to have other people connecting in. If they are connecting, they show up on that little radar, but right now it's just standalone. And also I can touch, and you'll see a little pointer floating around here as well. So it's using the touch events to capture that as well. So this is equivalent of a native card app like you were talking about before, but it's all running on the device and everything. So it shows you can build more complicated applications too.
So I guess these apps basically run as a single card function.
That's right, yes, exactly. Yeah. So that's what I want to show you for now. What I want to do is go around and see if first of all, see if anybody has any questions, and then see if you've each got processing running on your own machines. So what we use processing for in the lab is that we can wrap a prototype with some ideas on processing, and then sometimes processing isn't fast enough to actually, like the camera app I showed you before, it's not fast enough to run the apps at full frame rate. But then when we've mocked up a user interface and tested it out and we know it's what we want, then we can go back and rewrite this thing in Java and get it running much faster. So for the purposes of your projects this week, you can either, you could build a mirror API project which doesn't involve any on-device native coding, or you could, if you're quite confident with Java, you could build an Android app with Java, or if you want to get something working very fast, you could use processing and get it working up fast as well, and then if you have time later on, maybe redo it in Java as well. So do any of you have any questions about that? Straightforward?
So when you said that processing runs on top of Java,
yes.
How does it compile into bytecode, or does it compile into Java and then into, I was wondering why it was slow?
So my understanding, and I'm not a Java expert, my understanding is that it's written in Java, so that it takes these lines of code, converts them to Java, and uses the Java compiler to build the APK files. I mean, it pushes. That's why it's taking so long when it compiles. It has to go through this process and then push the APK file onto the device itself.
Okay.
And then when it's running, you're running through multiple layers of libraries, so it can run quite slow.
Okay.
Yeah.
Would we install this? Strength.
No, that shouldn't be. If you've tried playing the games that are on Glass, there's there's a game where you point your head and shoot at targets and things like that. They run very fast, and they're all written with the native GDK. So the screen refresh rate doesn't have any impact on the performance, really. It's just that you're basically emulating the Java code, and the emulation is a big performance hit. Yeah, but it's fine for a lot of things. Like I think your app, you're thinking about doing some sort of a currency conversion. Is that right? So you could easily use this to mock up the flow of the app. I think you're thinking about using character recognition to recognize handwritten numbers or something. So processing, I don't think will let you do that, although I wouldn't be surprised if somebody's written a processing OCR library that you could import. But what you could do is you could use processing to capture the image from the camera, and then you could send the image off to a server, do the processing, and then come back as well. Because with the Ketai library, you also have access to Bluetooth and Wi-Fi networking libraries as well. So you could wrap that on there as well. Does anybody have any other questions? Great. So what I'll do now is I'll go around and check to see if you've got the code running. There was an issue with my laptop, and some of you may have the same problem. It turned out that when they released the new version of processing, which is 2.1.1, they broke a little bit the Android building. So what Gunn had to do to get it working was he had to put a symbolic link in to show processing where the Java compiler was, and then when he added that, it worked fine. So if you've got the most recent version of processing, it might not work, but you can go, and what I did last night is I went to the processing website and downloaded the version before that, 2.0.3, which I'm running right now, and that works just fine. So there's workarounds. So as I guess you were saying before, processing requires you to have the SDK 10 of Android installed. So you should have an Android SDK manager running, and you can go back and install 10 as well. I think Glass runs on 15 or 17, I can't remember. 15, that's right, yeah. But you have to install 10 as well. If you don't have 10, when you try and build something, you'll have an error appearing saying you can't build it. So, have any of you been able to successfully get, I think you've got it running on your one, haven't you? Did you get it set up okay?
I mean processing?
Yeah.
Yeah, I got a little demo app running.
Great, excellent.
Yeah.
Great, so that's 2 down. How about you, Neville? Okay, great. Well, I'll put you in the hard basket, and we'll keep on going.
I've got the problem you were talking about where Jesus and Bible.
So why don't you download the older versions? If you go to the processing website, you can download the 2.0.3 version, which is the old ones. How about you guys on the back?
The startup script. I don't want to do that.
I fixed that.
Oh, do you want to show me?
Yeah, that's great.
I fixed that there exactly over there. Core.